Okay, so this first question here, algebraic fractions, we need to simplify this expression here. Notice that there's no equals to sign. We have a plus sign here. So what we're going to be using is up, basically just multiply across the 8 and the 2. And then to get the denominator, we're going to get bottom boys. See, when there's a plus here, and this says simplify, we're just going to get something like A over B, where like A and B or whatever, numbers, letters, whatever combination. Basically, we're getting another fraction. We're not solving for x. So what we're going to do is multiply the 2 across to the 7x, and we're going to get 2 times 7x, and the 8 across to the 3, so 8 times 3. Then for the denominator, bottom boys, multiply these two guys, 2 times 8. Now, simplify this. 2 times 7x is going to be 14x, and 8 times 3 is going to be 24, all divided by 2 times 8, which is going to give us 16. Now, this is not fully simplified. We notice that everything in this fraction can be divided by 2. So I'll continue this down here. Factor out a 2 from the top. You're going to get 2 times 7x plus 12. And then from the bottom, we're going to have just 2 times 8. Then these 2's can actually cancel. And that's going to give us 7x plus 12 divided by 8. And that's the final simplified fraction. See, we cannot factor out anything else from the top or bottom, so we know we're done. This question here, however, there is an equals to sign. So we're still going to use up every time we're going to cross multiply, but we're not doing bottom boys because we're actually going to solve for x. We're not writing it as a fraction, we're solving for x. So what we're going to have here is 3 times 2x plus 4 is equal to 2 times 4 times x plus 1. So distribute the bracket, 3 times 2x is going to be 6x, and then 3 times 4 is going to give us 12. Then that's going to equal 8 times, because 2 times 4 is 8, 8 times x plus 1, which is going to just be 8x plus 8. Now, we want to solve for x here. Notice it says solve. So we're going to bring the 6x over to this side and bring the 8 over to the other side. What we're going to get then is 12 minus 8 is equal to 8x minus 6x. Because again, we want to solve for x, so we want all the x's on one side, everything else to the other. Then 12 minus 8 is going to give us 4, and 8x minus 6x is going to give us 2x. That means that x is equal to 4 divided by 2, which is equal to 2. That's our final answer. X equals 2. If you want to make sure your answer is correct, you can just plug 2 in here for x and see if you get the right answer. So like 2 times 2 is going to be 4, plus 4 is 8, 8 divided by 2 is 4. And then if you fill it in here, we're going to have 4 times 2 plus 1 is 3, so that's going to be 12, which divided by 3 is also 4. So we know we're right. Moving on, next question here is simultaneous equations. Solve the following system. 2x plus 3y is 13, and x minus 2y is equal to negative 4. To solve these, we need to either get rid of the x's or get rid of the y's. Well, if I multiply this bottom equation by minus 2, I know I can cancel with the plus 2 on the top. So that's what I'm going to do. I'm going to multiply this bottom one by minus 2. When I do that, the top one will remain as 2x plus 3y. 3y is equal to 13. And the bottom one is going to become negative 2x, because we're multiplying it by minus 2. Multiply minus 2y by minus 2, we're going to get a plus 4y is equal to minus 4 times minus 2 is going to give us 8. Now, we're going to add these together. The 2's are going to cancel. The 2x's are going to cancel, I should say. 3 and 4 is going to give us 7y is equal to 8 plus 13, which is going to be 21. That means that y is equal to 21 divided by 7, which is 3. So here we have y equals 3 now. We also need to get x. So what we're going to do is we're going to fill into the original equation with y equals 3. I'll fill into the second one. So we have x minus 2y, but y is 3, is equal to minus 4. That means that x minus 6 is going to give us minus 4. So x is equal to minus 4 plus 6, which is equal to 2. So our final answer is x equals 2 and y equals 3. Boom, like that. Now, algebraic long division. We're going to be dividing this whole expression here by 2x minus 1. So what we're going to do is we're going to write 2x minus 1 here. and then our equation 14x cubed minus 29x squared minus x plus 6, like that. Now, we're going to be using the same system over and over again to solve this. First thing, divide the number in the front by the number in the front here. So here we have 2x, divide that into 14x cubed, we're going to get 7x squared. Then, multiply the 7x squared down to these two lads. So, 7x squared times 2x is going to be 14x cubed. 7x squared times negative 1 is negative 7x squared. Draw the line. Now, this next step, pretty confusing. There's no real justification for it. We have to change these signs here. Then when we do that, these 14x cubes are going to cancel, and we're going to have minus 29x squared plus 7x squared. That's going to give us minus 22x squared. Final step, bring down these lads, minus x and then plus 6. Now, what do we do from here? Same thing again. Rinse and repeat. Divide the negative 22x squared by the 2x. We're going to get minus 11x. Multiply him down. So negative 11x times 2x is going to be negative 22x squared. And then negative 11x times minus 1 is going to be plus 11x. Like that. Draw the line. Flip the sign. That's going to become a plus. That's going to become a minus. Then these are going to cancel. Negative x minus 11x is going to be minus 12x. Don't forget the 6. Bring down the 6. One more time. Minus 12x divided by 2x is going to be minus 6. Multiply across. We're going to get minus 12x. And then minus 6 times minus 1 is going to be plus 6. This is generally how you know you're right. When these numbers at the bottom, when we flip the sign here, this is going to become positive. That will become negative. These are going to cancel. The 12s will cancel and the 6s will cancel, and we'll have a 0 here. Generally, unless the question states that you need to get a remainder, which the remainder will normally go here, the remainder here is 0. So we kind of know that this is going to be the answer. So when we divide this expression here by 2x minus 1, I'll highlight it. This is our final answer. This is the result of the division, and that's the answer. Now, factorization. We want to factorize the following expressions and label which method we use. This first guy here, we notice that there's 4 terms here. So I would say it's more than likely we're going to be grouping terms here. And if we look, like, okay, this 5xy does have a y in common with the minus 2y squared here. But, you know, it would actually have more in common with the 15x because they have a 5 in common and the x in common. Same here. This minus 2y has a lot in common with the minus 6 here. They have a minus 2 in common and a y in common. So we're going to be changing the equation to group-like terms. So we have 5xy plus 15x. Then we're going to have the minus 2y squared minus 6y. We're just going to separate them. That's what we want to group the top 2 together and the bottom 2 together. When we group these two, we're going to see they have a 5 in common and an x in common. So we can rewrite this equation as 5x bracket. Now what goes in the brackets? We're going to be dividing these guys here by 5x. So the 5xy divided by 5x will have a y. And then the 15x divided by 5x, we're just going to have a plus 3. Like that. Then the next guys, they have a minus 2y in common. And now again, we're going to divide each of these by minus 2y. We're going to get a y plus 3 again. Now, we can factorize this one more time. We see they both have a y plus 3 in common. So we can rewrite this as y plus 3. We'll factor out the y plus 3. And then we'll write the rest in brackets. So we're going to have the 5x minus 2y in brackets like this. And that's the answer to that question. That is that equation fully factorized using grouping and highest common factor. It's kind of a combination. Whenever you use grouping, you're going to use highest common factor as well. Highest common factor as well. Now, this guy, you have to spot. This is a difference of 2 squares. Difference because of the minus sign. We have 2 expressions, 2 little equations, and squared. The 4 is the same as 2 squared, and the 36 is the same as 6 squared. So you need to spot that this thing here, we can rewrite as 2x all squared minus 6y all squared. Now, Remember, the formula for difference of two squares, I'll write it in a different color. I'll write it in blue. We're going to have x squared minus y squared, that should be a y, is equal to x minus y times x plus y. That's a crucial formula you need to remember. You have to be able to recognize this, and you have to remember what the equation actually is, because there's no way you could really solve this otherwise. So we're going to rewrite this down here. This is going to just be 2x minus 6y times 2x plus 6y, just like that. And that's that factorized using difference of two squares. Then, last one, we have 2x squared plus 11x plus 5. You have to notice this is a quadratic. Boom. This is a quadratic, written terribly. But you have to notice, whenever you have something that looks like something x squared plus something x plus something, that's a quadratic. We're going to be using quadratic factorization. So what we're going to do is we're going to write out the factors of the number in front of the x squared and the number at the end. The factors of 2 are just 2 and 1, and the factors of 5 are just 5 and 1. Now, we need to find a combination that will add to 11x here in the center. So if we multiply the 2 to the 5, we're going to get 10. And if we multiply the 1 and the 1, we'll get a 1. 1 plus 10 is 11. So if we take both of these to be positive, we're going to get our 11x we need. Notice also, when we multiply these, we're going to get the 5 we need as well. So now we know what we're working with, the numbers at least. Draw the brackets. We're going to put the 2x over here and the 1x over here. Now, key here is the 2x is multiplying with the 5, so they have to go in opposite brackets. Because if they go in the same bracket, they're never going to be in a scenario where they can multiply with each other. So we're going to have 2x plus 1 times x plus 5. And if you're ever unsure, you can multiply these brackets out using split and repeat or whatever method you prefer. But this is the correct answer. This is that equation there, fully factorized, just rewritten. And that's all there is to that factorization question. Okay, next question here is the sum and difference of two cubes. We want to factorize these two equations using either the sum or difference of two cubes. Looking at this first equation, we notice immediately we have a minus sign there. We're going to be working with a difference. We have an x cubed, we have a y cubed, and notice 27 is just 3 cubed, and 512 is just 8 cubed. So we know we have a difference of two cubes. And the formula for that, if we have x cubed minus y cubed, we can factorize that as x minus y times x squared plus xy plus y squared. Now, all we have to do from here, since we know the formula, we're given the formula, we just have to factorize this. Looking at this, we can say 3x all cubed minus 8y all cubed can be factorized as x minus y. So we're going to have 3x minus 8y, y, times x squared plus xy plus y squared. So x squared is going to just be 3x squared. That's going to be 9x squared. X times y. So 3x times 8y is going to be plus 24xy. And then we're going to have the 8y squared, which is going to be 64y squared, like that. And that's our factorized using the difference of two cubes. Looking at this next one, we have a plus sign, so we're having a sum. X is cubed, y is cubed, 8 is just 2 cubed, and 343 is just 7 cubed, I believe. Because if you ever want to check, you can just do into your calculator the cubed root of what? 343, and that is 7. So we have, this is the same as, well, I'll write down in a second. So for a sum of two cubed, we have x cubed plus y cubed can be written as x plus y times x squared minus xy plus y squared, like that. Now again, we know the formula, we have our equation, now we just need to fill in. So we can say 7x all cubed plus 2y all cubed is equal to 7x plus 2y times 7x squared is going to be 49x squared plus We have 7x times 2y. We're going to have 14xy. And then the 2y squared will give us plus 4y squared, like that. And that's that factorized using the sum of two cubes. Now, simultaneous equations. The other one we did was in 2 dimensions, so it was just x and y. This one is in x, y, and z. So now it's the same process as the last one since it's still linear. Linear just means it's not multiplying with anything or anything crazy like that. It's just 3 simple equations. We're going to have to cancel either the x, y, or z first. And when we do that, we're going to get 2 more equations from those, and then we just solve it as the same as we did with the first one. So, looking at this immediately, I'm going to cancel the z's. So, I'm going to deal with these 2 equations first, and then I'm going to deal with these 2 equations here after. So, let's work with these first. So 3x plus y minus 2z, and then we have x minus 3y plus 4z. I want to cancel the z's here. So if I multiply this top equation by 2, I'm going to get a negative 4z. And when I add that to this 4z, they're going to cancel. So I'm going to multiply this top equation, just the top equation, by 2. So that's going to give me 6x plus 2y minus 4z is equal to 14. Again, just multiply everything in the equation by 2. And I'm going to leave this second equation as it is. So we're going to have x minus 3y plus 4z is equal to 15. Now, the z's are going to cancel. And now, add these. We're going to have 7x, 2y minus 3y is going to be minus y. And that's equal to 14 plus 15. That's going to be 29. Now, label this. This is number 1. Equation 1. Put it in a box. Don't forget about it. We'll come back to it later. Next equation, or I should say system of equations, we're going to do down here. X minus 3y plus 4z is 15, and then 2x minus 2y plus z is equal to 12. Again, I want to cancel these. I'm going to cancel the z's, so I'm going to multiply this bottom equation by negative 4. Because then I'm going to get a negative 4z here, and when I add that to this equation on top, they're going to cancel. So, top equation, x minus 3y plus 4z is equal to 15. And then multiply the bottom one by minus 4. I'm going to get minus 8x plus 8y minus 4z is equal to 12 times 4, 12 to 48, minus 48. Now, the z's are going to cancel. We're going to get a negative 7x and then a plus 5y, because 8 minus 3 is 5. And then a negative 48 plus 15 is going to be negative 33, like that. And this is equation 2. Put a box around it. Now we have 2 equations with x and y. So now we just have what we did in the last question earlier on with the simultaneous equations. We just have 2 equations with x and y. We're going to cancel either the x's or the y's, and we're going to solve the rest of the equation. So we have 7x minus y is equal to 29, and then minus 7x plus 5y is equal to minus 33. Luckily, these 7s are going to cancel already. So we'll just do that. And then we're going to get a 4y here, because 5 minus y. And then we're going to have 29 minus 33, and that's going to be negative 4. So then we have y is equal to negative 1. Boom. First answer gotten. Now we need to get x. So we're going to fill into either of these original equations. I'll fill into this one here. So we have 7x minus y, which is negative 1, is equal to 29. That means that 7x plus 1 is equal to 29. That means 7x is equal to 29 minus 1, which is 28. So x is equal to 28 divided by 7, which is 4. Boom. Second answer. Gotten. We're running out of space. But the last step here, we just need to fill in x and y into any of these equations to get the z value now. I'll fill into this top one, I guess. So it's going to be 3x, so 3 times 4, plus y minus 2z. So y is minus 1, minus 2z is equal to 7. Perfect. Now, 3 times 4 is 12 minus 1 minus 2z is equal to 7. So 12 minus 1 is going to give us 11. So we're going to have minus 2z is equal to 7 minus 11. That's going to be minus 4. So then z is equal to minus 4 divided by minus 2, which is just 2. So boom. That's our final answer. y is minus 1, x is 4, and z is 2. And if you want to confirm that, if you fill in those x, y, and z values into any of these equations, you should end up with these numbers at the bottom or at the end, depending on which equation you fill into. That's how you know if you ever want to check if you're correct, you can just fill into the original equations. And that's that question done. This system now is different to the last one. Notice this one is non-linear. That's because we have terms multiplying. So when we have terms multiplying, we don't solve them the same way as the last one. Well, this first equation here, we have 3x minus y is 9. But then we have x times y is 12. We want to solve for x and y. Well, what I can do is I can fill in for y here using this. Since y is equal to 12, that means that y is equal to 12 divided by x. So now I can just fill that y value into this equation here. So we have 3x minus 12 divided by x is equal to 9. We want to solve this for x. Immediately, get rid of the fraction. The fraction is making this equation pretty complicated. Let's get rid of it. Multiply everything by x. 3x squared minus 12 is equal to 9x. Let's bring over the 9x. So that's going to become 3x squared minus 9x minus 12 is equal to 0. Now, this is just a quadratic. I could solve this, but I'm actually going to divide everything. Everything is divisible by 3 in this equation. So I'm going to just simplify it by dividing by 3. X squared minus 3x minus 4, like that. Now, same as always, we want to factorize this quadratic. Factors of the 1, and then the factors of the 2, 1 and 4, and 2 and 2. I notice to get negative 3, I'm going to want a negative 4 and a positive 1. So that's just going to be x minus 4 times x plus 1. And again, if you multiply this out, you should get the original equation here. So for this to equal 0, either this bracket must be 0, so x minus 4 is equal to 0, then x is equal to 4, and then we have x plus 1 is equal to 0, or x is equal to minus 1. That's just because if this equation is equal to 0, either this bracket here must be 0, or the bracket on the right must be 0. So we have two values for x now. X is 4 and x is minus 1. So we need to fill in these x values back into the original equation. I'll fill them into this guy. So we have y is equal to 12 divided by x. We know that. So I'll write it again. Y is equal to 12 divided by x. So if x is equal to 4, then y is equal to 12 divided by 4, which is 3. Boom. But if x is equal to minus 1, then we have y is equal to 12 divided by minus 1, which is just minus 12. Because 12 divided by 1 is just 12. Anything divided by 1 is just itself, but we have the minus sign as well now. So our answers are, to solve this for x and y, the answers are x equals 4 and y equals 3, or x equals minus 1 and y equals minus 12. So those are the, see now, we get two values for x and two values for y. That's generally how you'll end up with non-linear equations. You're going to end up getting two values for x and two values for y. Important to distinguish them. So this x value gives you this y value, and the other x value gives you the other y value. And that's all there is to non-linear equations. Next thing, algebraic identities. So these look pretty complicated. They're actually not bad at all. So we want to solve for a, b, and c in this following expression. Now notice we have an x squared, x, and a number, x squared, x, and a number. So all we need to do is match it up. So there, we're going to match up the x squareds first. So matching up the x squareds, we're going to have the 4 must equal to the square root of b. That means that b is just 4 squared, and that's just 16. So we have our first letter instantly. B is 16. Now, let's look at the x terms. We have a minus 4 is equal to 8c, because they're both with the x's. So minus 4 is equal to 8c. That means that c must equal to minus 4 divided by 8, which is equal to minus 1 over 2. So c is minus a half. Now, last thing, a is equal to minus 1. And I think that's just it. There's just a constant term here. We just have a is equal to minus 1. So a is minus 1, c is minus a half, and b is 16. That's the answer to that question. This one, Same thing, solve for a, b, and c. So again, let's start with the squares. So in the x squared terms, we have b cubed is equal to 27. That means that b must equal to the cubed root of 27, which we know is just 3. So b is 3. Then the x terms, we're going to have minus a plus 1 is equal to minus 23. So minus a plus 1 is equal to minus 23. That means that a plus 1 is equal to 23. That means that a is equal to 22. So a is 22, b is 3. Last thing then, notice we don't have a number on its own in this first equation here. So for this equation to hold, c must be 0. And that's because then, if we fill in a and b into this original equation, we should get this equation here. But we don't have a number on its own in the first equation. So that means c must be 0 because it has no number to go with it. So whenever you're doing algebraic identities, just remember, match up the x squared terms to each other, match up the x terms to each other, and match up just like the numbers on their own to each other. Now, cubic equations are crucial. You're more than likely going to have to do one in your Leaving Cert, but they're kind of tricky. They include a lot of guesswork and algebraic long division, so it's important you get good at that as well. Now, we want to solve this equal to 0. First thing we're going to have to do is guess what the first x value is. See, these are all positive, so for this to be 0, I'm going to only plug in negative x values. So if I try say x is minus 1, I'll say x equal to minus 1. Then we're going to have 2 times minus 1 cubed plus 9 times minus 1 squared plus 13 times minus 1 plus 6. Now, minus 1 cubed is just going to be minus 1, so that's going to be minus 2. Then we're going to have a plus 9 because minus 1 times minus 1 is plus 1. Then minus 13 and plus 6. That's going to be minus 2 and minus 13 is minus 15. And 9 plus 6 is 15. So that's just going to be 0 because they're going to cancel with each other. So we know x minus 1, key here, key. So x equals to minus 1 is a factor. Or is it? Yeah, it's a factor. That means that x plus 1 is a root. So we have a root. How do we get the other 2 roots? Because this is a cubic equation, it has 3 roots. Long division, x plus 1. We're going to divide that into 2x cubed plus 9x squared plus 13x plus 6. You already know the method. We're going to divide into the first number, 2x squared, multiply down, 2x cubed plus 2x squared. Draw the line, flip the sign. That'll become a minus, that'll become a minus. Then we can cancel the 2's. And we're going to have 9x squared minus 2x squared. That's going to be 7x squared. Bring down these guys. Plus 13x plus 6. Again, 7x squared divided by x. We're just going to get a plus 7x. Multiply down. 7x squared plus 7x. Draw the line. Flip the sign. Minus, minus. Then these 7s are going to cancel. 13 minus 7 is going to be 6x plus 6. One more time, divide in, we're going to get plus 6 here, multiply across, we're going to have a 6x plus 6. And again, we know we're right now because when we draw the line and we flip the sign, all of these are going to cancel and we're going to be left with a 0 down here. So now we have this quadratic here, 2x squared plus 7x plus 6. 2x squared plus 7x plus 6. We got that when we divided the original equation by x plus 1, yeah. So now we know x plus 1 is a root. So now we need to get the other 2 roots of this. So this is equal to 0. And again, this is just quadratic factorization. Factors of 2 and then the factors of 6 are 1 and 6 and 2 and 3. Now we need a combination that will give us plus 7. I can see immediately the 1 and the 6 here are going to do nothing for us. 2 times 2 is 4. And then 1 times 3 is 3. And if we take the positive of both of these, 2 times 2 is 4, plus 3 is 7. And then when we multiply these, we're going to get our 6. So then, draw the brackets, 2x here, and the x here. 2x is multiplying with the 2 here. So they have to go in opposite brackets. and the 1 is multiplying with the 3, or the 1x, I should say, is multiplying with the 3. They are in opposite brackets as well. Now, these are equal to 0. So, for those to equal 0, this bracket must be 0, or this bracket must be 0. So, if 2x plus 3 is equal to 0, then x is equal to minus 3 over 2. And if x plus 2 is equal to 0, then x is equal to minus 2, like that. So those are our two x values. Now, the final answer then is x equals minus 3 over 2, minus 2, and from the original equation, minus 1. Minus 1. That's our answer. You could also write what the roots are, so you would have like x plus 3 over 2, and then x plus 2, and then x plus 1. But here we're saying solve, and whenever they say solve, they want the x values. So for that to equal 0, it's x equals minus 3 over 2, minus 2, and minus 1. Okay, moving on to inequalities. Solve the following inequalities. We have mod 2x minus 1 must be greater than 1. So that means if the modulus, remember, the modulus just means we're taking the absolute value. So if I have like mod of negative 4, that's just going to give me back 4. So you want this number here, we want its magnitude to be greater than 1. And for that to be true, it must be 2x minus 1 must be greater than 1, or 2x minus 1 must be less than negative 1. Those are the only cases where this bracket here, the number on the inside, will be greater than 1. So for 2x minus 1 to be greater than 1, that means that 2x must be greater than 2 when we add 1 to both sides. Remember, the greater than sign or equal to sign, or the greater than equal to sign, the less than sign, whatever, we can just treat them the same as an equal sign. So we can like add 1 to both sides, and then when we divide by 2, we're going to have x is greater than 1. And then here, we're going to move the minus 1 across. So that's going to be 2x is less than 0, or dividing by 2, x is less than 0. So that's the answer to that first question. For this to be greater than 1, remember, we're taking the modulus, it's either x has to be greater than 1 or x has to be less than 0. Now, this one is a quadratic. Slightly more complicated, but I'm going to show you a method I always use. X squared plus 3x plus 2 is less than or equal to 0. First thing, let's just treat this as a regular quadratic. So let's say x squared plus 3x plus 2 is equal to 0. Let's solve this normally. Again, factors of 1, factors of 2. 1 times 2 is 2, 1 times 1 is 1. If we plus them, we're going to get 3, and when we multiply them, we'll get positive 2. So we have x plus 2 times x plus 1 is equal to 0. So x plus 2 is equal to 0 will give us x is equal to minus 2. And x plus 1 equals to 0, then x is equal to minus 1. So we just got the roots of that quadratic here. So if I draw a graph, I'll draw it in red real quick. If I have a graph like this, we'll say, it's very rough, but, vaguely. This function is going to look something like this, because it's a positive x squared. I know it's going to look like a happy face. And I just got the roots here. So here is going to be minus 2, and here is going to be minus 1. Now, I want to find where this function here is less than or equal to 0. Remember, the function is like this curve here. I should have drawn it in blue. I'll draw over it in blue. What I have there in blue is just this equation. And we want that less than or equal to 0. For this to be less than or equal to 0, we're talking about the region down here, the negative y-axis, because up here is the positive y-axis. We're talking about this region down here. So this equation is less than or equal to 0 for the x values between minus 2 and minus 1. So like this region down here. That means that our answer is going to be minus 2 is less than or equal to x, which is less than or equal to minus 1. So basically, this function here is less than or equal to 0 when x is between minus 2 and minus 1, with equality as well. I'll draw a little note that if this equation, imagine this greater than or equal to sign was or this less than or equal to sign was a greater than or equal to sign, then we would be talking about the regions to the left and right of the graph, like up here. And that would mean x has to be less than negative 2 or equal to, or x has to be greater than or equal to negative 1. So those are the two cases. Depending on whether you have a greater than or equal to or a less than or equal to sign, it determines what region of the graph you're looking at. I think sketching the graph is crucial because then you can actually see what region you're looking at. So here it's less than or equal to. So I know I'm looking at this region down here. If it was greater than or equal to, though, I would be looking at the region above this horizontal line here. So it'll be like this region here and here. So I know I'd be looking at x values down over here and x values to the right over here. That's not to do with the question, so I'll rub that out. That's just a little bonus note. But the answer to this question is -2 is less than or equal to x, which is less than or equal to -1. Okay, so the final example of inequalities we could have is a fraction inequality. Now, to solve these, obviously, this equation would be pretty easy to solve if we didn't have a fraction. So you think, okay, let's multiply both sides by x minus 4 to get rid of the fraction. That is correct, but you have to remember, for inequalities, if you multiply an equation by -1, we have to flip the direction of the sign. So to ensure we're not multiplying by a negative number, we're going to multiply both sides by x minus 4 squared. Just like this. And that's basically to ensure we don't have a, because we don't know the value of x minus 4. You know, if x was, I don't know, 6, we'd have 6 minus 4 is 2, which is greater than 0, which is fine. But if x is -6, we'd have -6 minus 4, which is -10. That's negative. So we can't multiply by a negative number. We have to make sure this is positive. So that's why we square it. Multiply that then on the other side as well, x minus 4 squared. Now, one of these is going to cancel with the denominator. So we're going to have x minus 4 times 2x plus 1 is greater than 4 times, and now I'm going to square this really quickly, x squared minus 8x plus 16. You should multiply this bracket out always, but just for the sake of time, that's the answer to it. And now we will expand this bracket. So we're going to have the x times 2x be 2x squared, x times 1 is just going to be x. Then we have minus 8x minus 4. It's going to be greater than 4x squared minus 8x. Sorry, not minus 8x, minus 32x, because we're multiplying in the 4 to this bracket, plus 64, like this. So, tidy this up, 2x squared minus 7x minus 4 is greater than 4x squared minus 32x plus 64, like this. Now, what we're going to do is we're going to move all of these over to the right-hand side here. So, we're going to minus 2x squared from both sides. So, we're going to have 0 is greater than 4x squared minus 2x squared. It's going to give us 2x squared. Minus 32x plus 7x is going to be minus 25x. And then the 64 plus 4 is going to be plus 68. So now we have, rewriting this, we have 2x squared minus 25x plus 68 is less than 0. Remember, we're dealing with less than 0 here. So, real quick, if I draw a graph, this is a quadratic, so we know it's going to look something like this, just by pure guess. It's going to look something like that. We have less than 0, so we're talking about this negative region down here. So we know our answer is going to be in this little region down here. Now, to solve this, we could use factorization, but there's a lot of factors of 68, so I'm just going to do the minus b formula. So, a equals 2, b equals minus 25, and c equals 68. And you already know, I will write it. So, x is equal to minus b plus or minus the square root of b squared minus 4ac divided by 2a. That's the minus b formula. And what we're doing, we're just plugging in a, b, and c into this equation. And you should get x equals 4 and x equals 8.5, I think, or 17 over 2. Make sure. Yeah. Now, these are our x values. These are the roots. These are these 2 points down here, even though they're not to scale because they're obviously positive. But you know what I mean. They're the roots of the function. So we're talking about less than. So the region in between them. So our answer is going to be 4 is less than x, which is less than 17 over 2, or 8.5, whichever you prefer. Remember, we don't have a less than or equal to or greater than equal to here, so we're not doing a equals to sign here. So 4 is less than x is less than 17 over 2 is the final answer. Next thing is surds. We want to solve the following equation. Surds is just a complicated way of saying like numbers or letters with square roots in them. So we want to solve x is equal to the square root of this thing. Immediately, let's get rid of the square root. We'll square both sides. X squared is equal to, when we square this, the square root will cancel with the square, so we're just going to have 10x minus 16. Let's rearrange. Bring everything over to one side. So x squared minus 10x minus 16 is equal to 0. We want to solve for x here. What is this? Just a quadratic. The amount of times you'll see a quadratic, you need to get good at solving quadratics. Know how to factorize them or know how to solve them using the minus b formula. They're crucial. So x squared minus 10x minus 16. The factors 1, and then the factors of 16. 1 and 16, 2 and 8, and 4 and 4. Immediately, we need a combination that will add to minus 10. So the 1 and 16 won't work, and the 4 and 4 won't work. If we do 1 times 2, and then 1 times 8, and these are both negative. Oh, sorry, that should be a plus 16. I was thinking that won't work. Yeah, if these are both negative, they'll add to minus 10, but when we multiply them, we will get plus 16. So we'll write it over here. Put the x's in the brackets first. Nope, I'm in the way. X's in the brackets first equals to 0. And these are both x's, so it actually doesn't matter which brackets we put these into. X minus 2 and x minus 8. Again, if you want to make sure you're correct, multiply these brackets out. But from this, if x minus 2 is equal to 0, then x must equal 2. And if x minus 8 is equal to 0, then x must equal 8. So that's the answer to this question. But to make sure, we need to fill into the original equation because we can't have this being negative in here. So let's try. If x is 2, well, let's plug in. 2 times 10 is 20, minus 16 is 4, and the square root of 4 is 2. So we're correct there. And if we fill in 8, 8 times 10 is 80. 80 minus 16 is 64. And then the square root of that is going to be 8. So yeah, those both work. So that's the answer to the question. This next guy is slightly more annoying. We have a surd on the left and the right. So to solve this, we want one surd on one side, another on the other. So square both sides. We're going to get rid of the square root here. We're going to have x plus 7. When we square this, we're going to have x over 2 plus... You should multiply this out always. When you square this, like you should multiply them in, but I'm just going to do it the quick way. When you multiply this with the 2, you're going to get 4 times the square root of x over 2, and then plus 4. That's that thing squared on the right. Now let's rearrange. We're going to bring the 4 over and the x over 2 over. So we're going to have x minus x over 2 plus 7 minus 4 is equal to 4 times the square root of x over 2. Like that. X minus x over 2 is just going to be x over 2. 7 minus 4 is going to be 3. That's equal to 4 times square root of x over 2. Now, I know this is going to get pretty messy if I leave this fraction here. So I'm going to multiply everything by 2. So I'm going to have x plus 6 is equal to 8 times the square root of x over 2. Now, one more time, we need to get rid of this square root. So I'm going to square it again. Square both sides again. So x plus 6 squared. Well, that's just equal to x squared plus 12x plus 36. Again, you should always multiply these out fully. I'm just using the quick methods just because I don't want to waste time. And that's equal to this thing squared, which is going to be 64 times x over 2. So we have x squared plus 12x plus 36 is equal to 64 times x over 2. Well, that's just going to be 32x. Bring everything over to one side. X, so 12x minus 32x is going to be minus 20x. And then plus 36 is equal to 0. Again, what do we have? A quadratic. We need to know how to solve this. I'm going to try factorize it. 1 and 1, and then we have 1 and 36, 2 and 18. Immediately, I need negative 20. I'm not even going to write out any more factors because I know this is going to work. 1 times 2 is 2, 1 times 18 is 18, and if these are both negative, they will add to minus 20 and multiply because minus 2 times minus 18 is plus 36. So we have x minus 2 times x plus 18 is equal to 0. So we're going to have x equal to 2 and x is equal, sorry, that should be negative. X minus 18, so x should be either 18 or 2, like this. Now, again, we need to make sure. So we'll fill into the original equation, x equals 2. So 2 and 7 is 9, square root of 9 is 3. And if we fill in 2 here, we're going to get 1, and 1 plus 2 is 3. So x equals 2 does work. If we try 18, 18 and 7 is 25, square root of 25 is 5. And if you plug it in here, 18 divided by 2 is 9, square root of 18 is 3, and 3 and 2 is 5. So they both work. So the final answer is x equals 2 or x equals 18. Now, indices, a lot easier than students make it out to be. They're crucial. You need to get good at these. You're going to see them very often. The rules are a bit tricky, but I think when you just practice them over and over, they actually become pretty easy. So this first guy, we want to simplify this. Well, when we multiply things with the same base, so these are just both x's, remember the first rule of indices, when you multiply things, you can just add their power. So x squared times x to the power of minus 4 is equal to x to the power of 2 minus 4. That's equal to x to the power of minus 2, because 2 minus 4 is minus 2. But we can rewrite x to the power of minus 2 as 1 over x squared. So yeah, that would be your final answer. Either x to the power of minus 2 or 1 over x squared. An easy way to remember this rule, by the way, is if you just have, like, say x times x. We all know that's x squared. But that's because both of these have an invisible 1 as the power. So when you do x to the power of 1 times x to the power of 1, when you add the powers, you're just going to get x to the power of 2. That's a little trick if you want to learn how to remember it. And then if you're doing division, it's the opposite of multiplication, so you're going to be minusing the powers. Moving on to this guy. X over x to the power of 5 over 2 times x to the power of 0. Immediately, x to the power of 0 is just 1. Anything to the power of 0 is 1. You can try it on your calculator, put any number to the power of 0, you're always going to get 1. So we can just ignore this. This is just multiplying by 1, so we can disregard it. Then, we're dividing. So we're going to have x to the power of 1 over x to the power of 5 over 2. That's equal to x to the power of 1 minus 5 over 2. 1 minus 5 over 2, that's the same as x to the power of 2 over 2 minus 5 over 2. And that's equal to x to the power of minus 3 over 2. Now, you could leave the answer as that, but just a note, x to the power of minus 3 over 2, that's the same as 1 over x to the power of 3 over 2. That's the same as 1 over x cubed to the power of a half. And remember, anything to the power of a half is just square root. So that could be written as 1 over the square root of x cubed. So it depends what kind of detail they want you to simplify it to. Like, they might say write it in the form, this, or whatever. But if you want to fully simplify this, that would be your answer. 1 over the square root of x cubed. Then, this final guy has a lot going on. We have a multiplication on top, a division on the bottom, and we have a power outside the brackets. So let's deal with what's in the bracket first. X cubed times x to the power of 7. That's just going to be x to the power of 10 divided by x to the power of 4 to the power of 2 over 3. That's equal to, we're dividing here, so we're going to minus the powers. We're going to end up with x to the power of 6 to the power of 2 over 3. Remember, when you have something to a power, we can just multiply the powers. So that's going to be x to the power of 6 times 2 over 3. And 6 times 2 over 3 is just going to be 4. So it's x to the power of 4 is the final answer there. Again, there's a lot of rules for indices, but you need to get comfortable with them because they're absolutely going to come up on your Leaving Cert. And once you get comfortable with them, they're actually not that bad. Then, similar to indices, final thing we're going to be doing today is logs. So we want to solve these equations with logs. Key with logs is say it in English. That's what I always say. So if we have log to the base 2 of 8 is equal to x. Let's ignore this equals to sign here. Log to the base 2 of 8. What that says in English is, what do I put 2 to the power of to get 8? And if I was to ask you, what do I put 2 to the power of to get 8? You would just say, 3, because 2 to the power of 3 is 8. 2 times 2 is 4, and by 2 is 8. So if we just remove this all again, we have what do we put 2 to the power of to get 8? Well, this equation says that 2 to the power of x is 8. So we can rewrite this as 2 to the power of x equals 8. So 2 to the power of something is 8. You could solve this using rules of logs, but this is pretty easy to see that x is equal to 3. Because 2 times 2 is 4, times 2 is 8, so we're going to be multiplying 2 3 times to do that. So that's the answer, x equals 3. This guy, however, log to the base x of 16. What's that saying? First of all, ignore the 2 for now. That's saying, what do we put x to the power of to get 16? Well, the answer is 2. So, we can rewrite this as x to the power of 2 equals 16. See here again, I think this rule is in your log tables. It's in on the top right, but it's like, if you have log to the base a of b equals c, you could say a to the power of c equals b. In both cases, we do that. So something squared is equal to 16. That means x must equal the square root of 16, which is just 4. So x equals 4 in this case. Okay, last question with logs. This is a very tricky question. There's a lot going on here, so you need to make sure you're really familiar with your rules of logs. First, I'm going to deal with the left-hand side here. We have log to the base 3 of 2x minus 2 minus log to the base 3 of 2. Immediately, they have the same base and they're minusing. So I can write it as log to the base 3 of 2x minus 2 divided by 2. And I can rewrite that as log to the base 3, as since there's a 2 in both of them, just x minus 1. Boom. That's the left-hand side simplified. The right-hand side, however, notice this base is 9. We want that base to be 3 to be able to solve this equation. We want it to be the same base as the left-hand side. We have to use this formula. It's log to the base b of x is equal to log to the base a of x over log to the base a of b. Basically, what this is saying is, if we want to change the base of our log, we just change the base, but we have to divide it by the new base to the power of the old base. So I'll just do that really quick. So log to the base 9 of 2x. We can rewrite that as log to the base 3, because that's what we want. We want base 3. Log to the base 3 of 2x over log to the base 3 of the old base, which was 9. Log to the base 3 of 9. What do we put 3 to the power of to get 9? Well, 3 by 3 is 9, so that's just going to be 2. So this is going to equal a half log to the base 3 of 2x. So we've just rewritten the right-hand side and the left-hand side. So now let's rewrite the whole equation. So we have log to the base 3 of x minus 1. Oh, actually, key here. This right-hand side, remember, another rule of logs, and probably one of the most important ones, is if you have something on a power, if you have a log to the power, you can move the power to the front. Likewise, if you have a number on the front multiplying, you can move it to the top as a power. So, log to the base 3 of x minus 1, we can rewrite as this log to the base 9 is 2x, we just said here, can be rewritten as this. And when we move the power to the top, we can write log to the base 3 of 2x to the power of a half, like that. Remember, anything to the power of a half is just the same as square root. I'll write that better. Yeah. Now, we have log to the base 3 on both sides. So we can technically just cancel these log to the base 3's. We're left with x minus 1 is equal to the square root of 2x. A much easier equation to solve. Now, square both sides to get rid of the square root. So we're going to be left with x minus 1 squared is equal to 2x. That's going to be x squared minus 2x plus 1 is equal to 2x. Or x squared minus 4x plus 1 is equal to 0. Whoa. Now, we can't factor this because we can't really get a combination that will add to minus 4. So just literally plug this into the minus b formula, where a is 1, b is minus 4, and c is 1. And you should get x equals 2 plus or minus root 3 from the minus b formula. Now, as a number, that will be x equals 3.73, or x is equal to, 0.26, or 0.27 when you round it. So those are the two x values we get, But again, we have to fill into the original equation. When we fill in the first guy here, I'll highlight him. This first guy here, we get no problems. But notice, when we fill in the second guy, the 0.27, when we try to take the log of this first part here, 2x minus 2, we're going to have 2 times 0.27, 2 times 0.27 minus 2. That's going to give us negative 1.46 in here. And another key rule with logs, we can never get the log of a negative number. You can never put something to a power and get a negative number. It's not possible. So we can never have a negative in this log. So that's why this second equation, or this second result here, actually doesn't work. So 3.73, or x is equal to 2 plus root 3, is the only solution to this equation. And that's the end. Boom.